Hello everyone, welcome to Code Enzyme. In this video, let's discuss problem C from the Hello 2024 contest of the Codeforces. But before starting this video, I would like you to hit that like and subscribe button because majority of my viewers have not subscribed to my channel and it doesn't cost you much but it will help me a lot. So let's first read the problem statement. You are given an array A of size n and you will do the following process to calculate your penalty. You have to split array A into two possibly empty subsequences S and T such that element of A is either in S or T. For an array B of size m, define penalty B as the number of indices such that Bi is less than Bi plus 1. So the total penalty you will receive is Ps plus Pt, and we want to minimize this penalty. And you can read the input format, and it is guaranteed that the sum of all discussions. So it is asking for an big of n or an n log n type solution. Let's first see and understand the sample input. So we have 1 2 3 4 5. So we have 5 1 2 3 4 and 5. Now let's calculate the answer for this. For now it is a completely increasing subsequence, right? So what we can do is we can split it into like 1 2 and 3 and then 4 and 5. So the answer will be 1 2 from here and 1 from here. So the total answer is 3, and you can try any other combinations. It will give you every time it will give you an answer of 3 whenever you split it into a 2 and 3 number of subsequences, right? Into two subsequences of length 2 and 3, and this is the optimal case. Okay, let's discuss another test case. This is 8 2 3 1 1 7 4 3. So I have 8 2 3 1 1 7 4 3. So we can let's try to make some subsequences. So I will make 1 8 3 1 1 and let's say 2 7 let's say 2 7 and 4. I think this covers 4 3. So if we see this is not contributing anything, but if we see Bi is less than Bi plus 1 for this case, and from here we get a 1, so our answer is 1 for this one. I mean, there may be other subsequences which were giving the same answer, but for all of them this is the minimum that I will get, right? And similarly you can try for other test cases. So now let's discuss the approach. Okay, let's try to understand this approach by using an example test case. So let's say if my array is something like 1 4 7 3 5 and 12. So now let's try to make two subsequences S and T, and from this we will try to calculate the answer. Now if my S is starting from one has to go in either of these, right? So let's say one goes in S for now. Now if I add my 4 in the S subsequence, it will increase my answer by 1 because 1 is smaller than 4, right? So I should add my 4 in the second subsequence, right? Because I am calculating indexes such that Bi is less than Bi plus 1. So I should definitely try to avoid this, right? So I will put 4 in here. Next I have 7. Now if I put whether I put 7 here or here, it will increase my answer by 1. So where should I put it? Now if you know that I am trying to avoid Bi less than Bi plus 1, then Bi should be as large as possible. Right, Bi should be as large as possible. That means if I put a 7 here, my Bi will be 7, and for here it will be 4. So 7 plus 4 is 11, which is greater. But if I put my 7 here, now this becomes a 1. So 7 plus 1 is 8, which is smaller, right? So in here the optimal thing to do will be to put 7 here. Next we have a 3. Now I can put a 3 here or here. Now which is more optimal? Like if I put my 3 here, so this will become 4 plus 3 equal to 7. But if I put my 3 here, this will become 7 plus 3 11, right? So I should put my 3 in the t subsequence, because I want to make bi as large as possible, right? And this step I am doing only when 3 is smaller than only when 3 is smaller than the last element of both these subsequences. Next I have a 5. Now I can put a 5 here also, that will make 7 plus 5 equal to 12, or I can put a 5 here, that will make okay, no, in this case, like 5 is obviously larger than 3, so this is going to increase my answer by 1, so I should definitely try to avoid this, and I will put my 5 here, right? Next we have a 12. Now if I put my 12 here or here, it doesn't matter, my answer is going to increase by 1, so I should place my 12 here, because 12 plus 5 is 17. So that is going to, if I had some more elements, so it will help me forming the answer. So these are the two possible subsequences which will help me solve the answer. So I hope you were able to understand this approach using this test case. Now I will try to live code this for you. Now I will also use this test case, like this one, 1 4 7 3 5 12. So I have 6 elements, 1 4 7 3 5 and 12, right? And the expected output is 2. I will use my template, and let's take the input first. So first we have an integer, then we have a list, map int input dot split. Okay, so I have this array now. Now I have two subsequences, s and t, right? Now I will traverse in this array, like, okay, let's say s will have my a0 element, right? And let's say for I in range 1 to n, if my len t is equals to 0, that means if my t array is empty, I should first check if my last element is greater than equal to if a of I less than equal to s of minus 1, then I will simply append it to append my a of I to s of minus 1. Then else case, I will say, okay, I will append it to to my t subsequence, and actually I can reduce this, so these two lines, and make the code shorter. I mean, this is not necessary, but you can try it. So a of I is less than equals to s of I, then append it. Now if this condition is true, like if then it is going to select t, right? So I will just swap it. So I've written the same thing using but I saved some lines here. In the else case, now I have some cases to consider. Let's try to go to the else case. Now the first thing we can say is let's try to handle the case when a of I is actually less than both the elements, so it is not increasing the answer. So s of minus 1 is let's say greater than equals to a of I, and t of minus 1 is greater than equal to a of I. So in both these cases my answer will not increase, so I will just copy this case here, and now here I can say, like, let's take s of minus 1 and t of minus 1. Now if my s of minus 1 is less than, then I should append it to s. I think you get the idea. If s of minus 1 is greater than equals to a of I, then what should I do? I should just append it to my s array, right? A of I, and same thing for my t. So t of minus 1, if the last element of t is greater than equal to this, then I will append it to this, and I've already handled when both of these are greater than, so I will just append it to the one with the lower value in the end. In the else case, now here in this case my answer will increase when I add in either of them, right? So what should I do? Like I have already tried to evade increasing my answer, So I should just select the one with the largest what should I say, element. So if my this is less, then I should append it to, I mean it is less, right? So I should change this, because a of I is less than s of I in both of these, so I should try to maximize my last elements. And now I will just have to count the number of positions the b of I is greater than b of I plus 1. So I will say okay, sum count plus equals to sum I for I mean not I, 1 for I in range uh, len s minus 1 if s of I is less than s of I plus 1. And then same thing I can do for t, and then let's print count. So this is giving me a wrong answer for this test case. I think I messed up somewhere. Okay, this should be the reverse and not that. And now both of these test cases are passing, and so this is the code. And now let's try to submit this code and see if it gives us a correct answer. So C problem. And you can see it passed the test cases, and I will pin this code in the comment section below. And if you have any other doubt, you can ask me in the comment section. And also, if you want a solution to a particular problem, you can comment down and I will probably make a video on it. So kindly like this video, and I will see you guys next time. Thank you.